Let's go over a couple of practice problems for quiz 4. Starting with question 1, we're told we have triangle ABC and it's a right triangle, so I'll put in that this is the right 90-degree angle. Can we use this triangle to find sine of A, cosine of A, and tangent of A? Here we're talking about the measure of angle A, so we need to know the definitions for sine, cosine, and tangent. I'll write down as a reference, SOHCAHTOA. And what this means is sine is defined as the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. And tangent is the opposite over the adjacent to angle A. I'm noticing that we don't know what the adjacent side is, so we need to solve for it. I'm going to call this side B. I'm calling it B because it's opposite the angle B. And we can solve for this by using the Pythagorean theorem. That is, this here is A, and this is C, and therefore A squared plus B squared is equal to C squared. If I put 16 in place of A, here I don't know B, but C is equal to 34 squared, we can solve for B squared if we subtract 16 squared to the other side of the equation. So that is B squared is equal to 34 squared minus 16 squared. I'm going to put that into my calculator. So 34 squared minus 16 squared. That is 900. And to solve for B, I can take the square root of 900. This gives me that B is equal to 30. Let me add that to the triangle. The length of B is 30, and we solve for it by using the Pythagorean theorem. Again, I set up A squared, B squared, and C squared. I subtracted the 16 squared to the other side to solve for B, applied the square root to get this answer. With these numbers, 16, 30, and 34, let's start by figuring out what is sine of A. Sine of angle A, by definition, is the opposite, 16 over the hypotenuse, which is 34. And that is it. By definition, sine is that ratio. Just like in the homework, you want to make sure that you reduce this fraction. I see there's a factor of 2 that can be canceled from the top and the bottom. Maybe I'll rewrite this again below here as sine of A is really equal to, that is 8 divided by 17. And that's it. Likewise, for cosine of angle A, let's see, cosine of this angle is the side adjacent to the angle, which is 30, divided by the hypotenuse, which is 34. So this is 30 over 34. Again, I think we can cancel a factor of 2. So dividing by 2 into 30 gives us 15. Again, dividing 2 into 34 gives us 17. And in reduced form, here is cosine of A. Lastly, what is tangent of angle A? By definition, if you're looking at this angle, tangent is opposite over adjacent. That's 16 over 30. Again, a factor of 2 can be canceled between the numerator and the denominator. That is 8 over 15. And here we go. These are the values of sine, cosine, and tangent, all based off of angle A. In question 2, we're told that in this right triangle below, so this isn't stated that it's a right triangle, but this looks like a 90-degree angle. We're told that the measure of angle A here is 28 degrees. I'm going to go ahead and fill that in. This is 28 degrees. We're also told that the length of side B, so this B over here, it's 140. And that's actually it. Using this information, can we determine what the length of side A is and the length of side C? We will round our answers to 1 decimal place as needed. So the trick for this problem is, if you first are solving for A, you'd like to use a trig function, either sine, cosine, or tangent, that incorporates this angle, this side, and this side. This is going to be tangent. Tangent is equal to, of this angle, the opposite over the adjacent. So for this reason, we can write down tangent of 28 degrees is equal to the opposite side, which we're calling A, divided by the adjacent side, which is equal to 140. In order to solve for A, you can take 140 and multiply it to the other side of this equation. This is equivalent to 140 multiplied to tangent of 28 degrees. That is the exact value of A. What I'm going to do is go to the calculator. I'm going to use the one that's posted in Desmos. I'm going to enter this expression. Be careful. Make sure that you are using degree mode, whatever calculator that you are choosing to use. Just make sure you do this so you evaluate this function correctly. So I'm going to type in 140 tangent of 28. So 140 times tangent of 28 degrees is, if I round to one decimal place, A is equal to 74.4. All right, moving on to solve for C. That's the other thing that we do not know. I'd like to use this angle, this given side, and connect those to C. So I need a trig function for this angle that is the adjacent over the hypotenuse. What is that? That is cosine. So cosine of angle A, which is 28 degrees, is equal to the adjacent over the hypotenuse, which is this divided by this. In order to solve for C, what I'm going to do is interchange the place of C and cosine of 28 degrees. You can swap these. So move C over here, put cosine of 28 degrees in this denominator. So C is equal to 140 divided by cosine of 28. This is what I'm going to type into my calculator, and I'm going to see what value that we get back. So 140 divided by cosine of 28 is, all right, so this value, when I round to one decimal, is 158.6. So that's the answer for C. Question 3 says, license plates in a particular state display 5 letters followed by 4 digits. How many different license plates can be manufactured for this state? This is a counting argument, and for this one, I'm going to list out the choices that we're going to be making. So 5 letters means we're doing 1, 2, 3, 4, 5 choices for letters, followed by, let's see, 4 digits, 1, 2, 3, 4 digits here. So again, these are going to be letters, and there are 26 possible choices for those, followed by these are digits, and of course there are 10 possible digits that you can choose. So that means in each of these spaces there are 26 choices that you can make. So the counting argument is, this is 26 times 26 times 26 times 26 times 26. Next to that, we can multiply by, well, for each digit, there's 10 possibilities, so I'll put a 10 in each of those spaces. And it is the product of these numbers that is the final answer to this problem. You can simplify this and write it as, all right, this is 26 to the power of 5. That's because there's 5 of these in a row. And to that, you're going to multiply by 10 to the power of 4. And that's because there are 4 10s in a row. I'm going to enter this into a calculator just to see what the expression is. So that's 26 to the power of 5 times 10 to the power of 4. Of course, this is a large number. So let's see, I get 118813760000. So it's this many here, which is quite large. So, I mean, really either this or this is an acceptable answer, but this is how you would count this number of plates. It's by using this property up here, multiplying the number of choices together. In the last question, question 4, it asks, how many different committees can be formed from 12 Republicans and 10 Democrats if the committee consists of 3 Republicans and 3 Democrats. So that is, we have 12 Republicans and 10 Democrats that are like volunteering, but we're only going to select 3 of the Republicans and 3 of the Democrats. For this type of question, you're making a distinction between, are you going to use the formula N permute R or N choose R? The formula that you use depends on whether the order matters in selecting these people or the order does not matter. And for this problem, the order does not matter. We are simply selecting people so they can serve on a committee. So we're not choosing this one, but we're going to use this one. And the reason is the order does not matter. We are simply selecting people for them to serve on a committee. We're not permuting them, we're just choosing them. So I'm going to use this formula here. And this really is a 2-step problem. In this first space, you're going to put the number of ways that you can select the Democrats. So this is where you select, I'll say select Republicans since they're first. And you're going to multiply that by the number of ways that you can select the Democrats. So what's the number of ways that you can select 3 Republicans from 12? Well, you'll put that number here. And then what's the number of ways that you can select 3 Democrats from 10? Well, you'll put that number here. What are those numbers? Those numbers are 12, choose 3. There are 12 Republicans, and we're only choosing 3 of them. This is the number of ways that you can do that. Over here, it's going to be 10, choose 3. There are 10 Democrats, and we're selecting 3. So we just need to know these 2 numbers, and then we need to multiply them together. So first, let's see, 12, choose 3. There's a formula for this. The formula is 12 factorial divided by, it's 12 minus 3 factorial times 3 factorial. I'm going to simplify this expression down. This is 12 factorial divided by, 12 minus 3 is 9 factorial times 3 factorial. Because 12 multiplies down to 1, you can do 12 times 11 times 10, and everything else will cancel with this 9 factorial. So this is 12 times 11 times 10. And this is divided by 3 factorial, which is 3 times 2 times 1, or 6. Well, 6 goes into 12 twice, so you can cancel 3, 2, and 1 into 12 with 2 left over. So this is 2 times 11 times 10. That's 22 times 10. That is 220. There are 220 ways that you can select 3 Republicans from 12. I'll do a similar computation for this, and then we'll put that number here as well. So we want to figure out, well, what is 10 choose 3? According to the formula, that's 10 factorial divided by, so this is 10 minus 3 factorial times 3 factorial. So this is 10 factorial divided by, that's 7 factorial times 3 factorial. 10 factorial is 10 times 9 times 8. And the second that you get to 7, it'll cancel with the 7 factorial in the denominator. That means 3 factorials left over in the bottom. That is 3 times 2 times 1. Here, I'll say 3 goes into 9 3 times, and 2 goes into 8 4 times. So when we simplify this, this is really 10 times 3 times 4. 3 times 4 is 12, times 10 is 120. So what is the final answer to this problem? Well, the number of ways that you can select the Republicans was 220. We're multiplying that by the number of ways that you can select the Democrats, which was 120. If you take the product of those 2 numbers, 220 times 120, that is 26,400. So 26,400 ways. It is that many ways that you can make this type of committee based on the people you are choosing from.